Hello all, good evening. So everyone had your dinner? Cool. Yeah, let's get started. So yesterday, let's try to just do a quick summary on yesterday's tasks. So what are the concepts that we covered yesterday? So initially we discussed about like what are data structures, like what kind of data is actually available in the market, and like why do we need to actually organize it in different fashions, whether it is tags or queues or like list or anything. So we thought of like based on different data types, we actually do a lot of things, right? Yeah, just give me a minute, guys. Let me do the recording. Yes, right. So yeah. So yesterday we discussed about why data structures is very important. Like even top companies actually prefer data structures, right? Like so we got to know what is the reason behind it. Why people are still obsessed with data structures. What is the reasons behind that, right? And then we started with recursion. We did a couple of examples, and today we are going to continue on recursion and like we'll try to understand like where exactly recursion is helpful and how can we like identify whether a particular problem should be solved using recursion or something else. So we'll try to understand those things today. Shall we get started? Cool. Okay. So let's just think about the recursion thing. What is recursion? And let me share my screen. So we'll also try to understand what are the key concepts here. First thing, like what are the four questions? What is recursion? When should we use recursion? And why should we use recursion? And how to use recursion, right? So let's go one by one. So first of all, what is recursion? So yesterday when we saw the code examples and all, we identified one thing which is like a function calling itself continuously. So we call that as recursion, right? So we also saw some examples with like counting numbers and also factorial. These are like some common examples. We'll also see more examples today, like which will help us in identify how recursion gives us better advantage. And the second part is when to use recursion. So why did we use recursion for like a Fibonacci program yesterday? What is the reason for using Fibonacci? So whenever we are using Fibonacci, we are trying to use a similar function with a different value, right? What is the formula for Fibonacci? Can anyone type it? You can type it in the chat box. What is the formula for Fibonacci? F of n minus 1 plus f of n minus 2. This is the formula for Fibonacci, right? F of n equal to f of n minus 1 plus f of n minus 2. And if you see, all the three functions are actually same, just the values are different, right? So when we identify this pattern, then we are using recursion, right? So now it is nothing but like a problem is being divided into multiple sub-problems of same type. Then we can use recursion. Do you agree with me? If we find a scenario, if we find a problem where we can divide a problem into multiple sub-problems and which are of similar type, then we can use recursion, right? Now, we'll also see a few more examples, like what are the different type of examples that we can try to do. For example, let me ask you one question. If I want you to count the numbers from 1 to 10, how are you going to do that? If I want you to count, add all the numbers from 1 to n, 1 plus 2 plus 3 plus, like let's say 10. So how are you going to do that? Can we use recursion here or not? Can we use recursion for adding numbers from 1 to 10? Yes. And how are you able to say that? There are two ways. One, you know recursion very well. Two, it's a standard question where recursion is applied, right? So now Let's try to understand. For this small example, how do we identify whether we can apply recursion or not? If I want to get a sum of all the numbers till 10, what can we do? Can I say something like 10 plus all numbers till 9? Will it work? I'm just trying to find, like get a value which is like 10 plus sum of all numbers till 9. And now, how do we get this value? Sum of all numbers till 9. How do we get it? Can we use the same formula again? 9 plus sum up to 8. Right? So here, if you try to observe, we are trying to break down the problem one step at a time. So instead of adding all the 10 numbers, what are we doing? We are like making it into two different parts. One is 10, the other one is the other value, which is still 9. Similarly, we are also doing it for 9, 8, 7, 6, and all. So when you can break this kind of thing, when you can come up with this kind of pattern, then you can say that we can use recursion. Do you guys agree with me? Similarly, even factorial also, we did the same thing. We are able to find a pattern where we can continuously use it and with the same function. That is why we thought like we can use recursion. But does it mean we can this problem should be solved only using recursion, or do we have any other options also? Can we solve Fibonacci problem only using recursion? Yes or no? Yes, no. So the reason is it can be solved in different approaches. Recursion is one of such approaches. And when you use recursion, code looks much simpler and easier to understand. That is the reason we prefer recursion. Otherwise, like there are other approaches using iterative approach. Using loops, you can do that. Now, like why are we using this recursion? As I just mentioned right now, there are two different approaches most of the times, iterative approach or recursion approach. If you use iterative approach, it becomes little tedious to understand the logic, like where exactly it is going into the next level and all. And the code becomes little longer. But when it comes to recursion, you are calling a function again and again. So that makes your code more readable. But which one has more performance in terms of like memory or time and all? Which is better, iterative or recursion? We will see that today. We'll get to know whether iterative approach gives us better code, better output, or whether recursive approach gives us a better result. Next, and how are we going to identify this particular pattern? We already thought that like there are some kind of problems which we can break down, and based on that, we are saying that we can use recursion, right? So now, how do we identify those kind of patterns? We will also try to understand those things. Okay. Now, so let's take one small example here. Can you see here this code? If you see this code, what is this doing? Can you tell me, anyone? There is a function with n as an input. Inside that, you have an if condition, n greater than 0. And then you are calling function of n minus 1. Now, assume that you don't have this line. Assume that you don't have this line. So now what is this particular method doing? Can you tell me? Anyone? Function of n, and inside that we are just calling function of n minus 1. So what exactly happens here? So let's say if n value is 3, what will happen? It will go inside, it will call n minus 1, which is 3 minus 1, a function of 2, right? Then again it like the 2 goes inside, and after 2 what happens? You are calling 2 minus 1, 1, right? And after 1 what happens? 0. Will it stop there? It is not going to stop because there is no condition. So after 0 what happens? 0 minus 1, minus 1. So after minus 1, minus 2. It keeps on going. And finally, what will be the output? We are not printing anything, we are not returning anything. So it just keeps on going, and finally you'll get a stack overflow problem, right? Because all the memory is gone. It is continuously going into an infinite loop. There is no end for that, right? When there is no end to a particular function, what happens? What error do we get? When it goes into an infinite loop, what error do we get? If you know, you can just put it in the chat box. Yes. We get stack overflow because there is a stack actually. The real term stack, we use stack. So now let's try to understand what exactly is that and why we are discussing about this stack in the recursive function. So when you say stack, what do you mean by stack? Stack ante enti cheppandi anyone? For example, the standard example is buffet, like buffalo, we use plates, right? How do we keep them? We keep them as like one on top of the other one, which is like a stack. Stack ante the simplest explanation is last in first out, right? Last ఏదైతే ఇన్సర్ట్ చేస్తామో అది ఫస్ట్ బయటకు వెళ్తుంది. It will go out first. Last in first out, which is LIFO. So now if you try to see here, let's take 10 as an example now. Okay, so మనం ఒకవేళ 10 ని తీసుకుంటే what happens is first it goes into a stack. Function of 10 అనేది ఒక స్టాక్ లోకి వెళ్ళింది ఇక్కడ, రైట్? కెన్ యూ సీ దట్? జస్ట్ a minute. Yeah. So first function of 10 went into stack, and then what happens? N value 10 ఉంది. So లోపల ఇప్పుడు function of n minus 1, which is function of 9, we are calling it, right? That gets into the stack, and then ఇప్పుడు n value is 9. So 9 minus 1, what is the value? 8. It goes on into the stack. Stack లో continuous గా వెళ్తూ ఉంటుంది. And since it is going into an infinite loop, what happens? Is stack, will it end at some point of time? It is going in an infinite loop, right? So it will just keep on going until the memory of the system is completely over, or మనం allocate చేసిన memory ఏదైతే ఉందో అది కంప్లీట్ గా క్రాస్ అయ్యేంత వరకు it will just keep filling it. And that's the reason we are getting stack overflow. అంటే మనం స్టాక్ కి ఇచ్చిన సైజ్ కంటే కూడా వాట్ ఎవర్ ద సైజ్ దట్ వీ హ్యావ్ గివెన్ ఫర్ స్టాక్, దీనికంటే కూడా చాలా ఎక్కువ మెమరీ, ఎక్కువ డేటా ఇన్సర్ట్ చేయడానికి ట్రై చేస్తున్నాం. దట్ ఈస్ ద రీజన్ వీఆర్ గెటింగ్ దిస్ ప్రాబ్లం. ఈ ప్రాబ్లం రాకూడదు అంటే ఏం చేయాలి? We have to add a base condition, which is this one. Can you see? If n greater than 0, what happens? If you add this if condition, function of 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and when it goes to 0, what happens? This condition, will it be true or false? It will be false. So automatically akkadto case end అయిపోతుంది, and then it will just keep returning these items one by one. Did you get it? Exactly. So it becomes false, and like everything will come out. Now let's try to understand how does yeah. So for example, let's try to take the same example. Yeah. So now for example, I'm taking like let's say 3 as an example. Okay, now here is my stack, and function first, what is the method? Function of 3, right? And then what happens? If n greater than 0, true or false? 3 greater than 0, true. It will go inside function of n minus 1. So function of 2, and then again it goes function of 2 వెళ్తే function of 1 వచ్చింది, right? And then now n value is 1, 1 greater than 0, it goes inside 1 minus 1. Now function of 0, When you call function of 0, what happens? 0, 0 greater than 0. Will it go inside? This condition is false now. So it will come to this line directly after the brace. So this method is completed. Now, when this method execution is completed, automatically this will be popped out because function of 0 is called and it is completed now, right? Now, what is the next thing? Function of 0 never call chesaru. Function of 1 call chesindi. So function of 1 kuda execution complete ayipindi. So even this will get popped out. Next, function of 1 never call chesaru, function of 2. So ఇది కూడా ఎగ్జిక్యూషన్ అయిపోయింది కాబట్టి ఇట్ విల్ జస్ట్ గో ఆఫ్. అలా మొత్తం టోటల్ గా అన్ని కంప్లీట్ అయిపోయేసరికి when the program execution is completely done, what is the size in the stack? The size of the stack is 0, right? So now let's try to understand దీంట్లో ఎన్ని ఆపరేషన్స్ జరుగుతున్నాయి అన్నది, so that we'll get to know how much time it is actually taking, how much memory it is taking. మనం 4 చేసినప్పుడు ఎన్ని ఆపరేషన్ స్టాక్ లో ఎన్ని ఎలిమెంట్స్ వచ్చాయి? We got, yeah, so basically when we tried for 3 we got like this one, this one, this one, this one, and this is the main method that we are actually calling, right? So this is not considered actually. Overall ga manaku vachindi 3, which means how much memory are we using it? మనం ఎంత మెమరీ యూజ్ చేస్తున్నాం ఇక్కడ? 3 blocks, right? Which is nothing but O of n. So usually మనము time complexity and like space complexity ని big O notation తో యూజ్ చేస్తాము. There are different ways to calculate these things. Like big O notation అనేది one of the most famous thing which like almost everyone uses. So అలా ఇక్కడ if you see how much time it is taking like n number of elements. n times ఈ మెథడ్ కాల్ స్టాక్ లోకి వెళ్తుంది. సో దట్స్ ద రీజన్ ద స్పేస్ కాంప్లెక్సిటీ ఈస్ యాక్చువల్లీ టేకింగ్ ఆఫ్ n ఎలిమెంట్స్, ఆర్డర్ ఆఫ్ n. అండ్ నౌ దీని కాల్స్ ఎలా జరుగుతున్నాయి? ఇఫ్ యూ ట్రై టు అండర్స్టాండ్, ఫస్ట్ ఏది జరిగింది కాల్? 3, అండ్ ఆఫ్టర్ దట్ 2, ఆఫ్టర్ దట్ 1, రైట్? ఇప్పుడు ఈ బేసిస్ మీద మీరు చూసుకుంటే కనుక లైక్ 0. This is like a tree structure. This will tell you how much time it is taking actually. మీరు ఒక్కొక్క మెథడ్ ని కాల్ చేసి అది మళ్ళీ రిటర్న్ రావడానికి ఏదైతే టైం ఉంటుందో దీన్ని బేస్ చేసుకొని వీఆర్ గోయింగ్ టు క్యాల్కులేట్ దాట్. అండ్ వాట్ ఈస్ లైక్ టైం కాంప్లెక్సిటీ హియర్? ఎన్ని ఆపరేషన్స్ జరుగుతున్నాయి? 3 ఏమో 2 ని కాల్ చేసింది 1 టైం, 2 1 ని కాల్ చేసింది, అనదర్ 1 2 అయింది, 1 0 ని కాల్ చేసింది 3. సో ఓవరాల్ గా లైక్ 3 కి 3 టైమ్స్ అవుతుంది, విచ్ ఈస్ నథింగ్ బట్ దిస్ ఈస్ ఆల్సో ఆఫ్ n, రైట్? So basically, if you are using recursion, like order of time complexity and space complexity are same for this kind of problems. Now, let's try to understand a little bit more. For example, if you see here, 10 ni తీసుకున్నాం అనుకోండి, చూడండి recursive tree ఎలా ఉంది? 10 will call function of 9, 9 will call 8, 8 will call 7, 7 6 అలా 0 దాకా వెళ్తుంది. సో ఓవరాల్ గా టోటల్ గా మనకి 10 టైమ్స్ కాల్ అవుతుంది. సో అందుకని the time complexity is of n. అలాగే స్పేస్ కాంప్లెక్సిటీ కావాలంటే do we see how many times it is being called or how many times it is being saved? Called or saved? Give your input on the comment box, guys. స్టాక్ లో నంబర్ ఆఫ్ ఎలిమెంట్స్ సేవ్ చేసుకోవడం అన్నది స్పేస్ కాంప్లెక్సిటీ రిలేటెడా ఆర్ ట్రీలో ఎన్ని టైమ్స్ కాల్ చేస్తున్నాం అన్నది స్పేస్ కాంప్లెక్స్ రిలేటెడా? So when it comes to space ante memory, right? So when it comes to memory, obviously stack related, and in stack we'll have the same number of elements. So andukane like for 3 elements we got 3 items, right? So we are saying space complexity is also of n, right? And ivanni possible ayede eppudu when we have the proper like exit conditions. We already seen, right? ఒకవేళ ఎగ్జిట్ కండిషన్ లేదనుకోండి, వాట్ విల్ హ్యాపెన్? ఇఫ్ యూ డోంట్ హ్యావ్ దిస్ ఎగ్జిట్ కండిషన్, విల్ ఇట్ వర్క్? ఇట్ విల్ గో ఇంటూ ఇన్ఫైనైట్ లూప్. ఆర్డర్ ఆఫ్ n కాదు, ఇట్ విల్ గో ఇంటూ ఆర్డర్ ఆఫ్ ఇన్ఫినిటీ, విచ్ ఇస్ నాట్ పాసిబుల్, అండ్ ఇట్ విల్ త్రో అన్ ఎక్సెప్షన్, రైట్? స్టాక్ ఓవర్ఫ్లో. ఎస్. సో నౌ ఇందాకే మనం అనుకున్నాం కదా, యా, we thought of like iterative approach వాడొచ్చు లేదా recursive approach వాడొచ్చు. What do you mean by iterative approach? Iterative అంటే we can use loops basically. For loop, while loop, do while loop, like any kind of loops. లూప్ యూస్ చేసేటప్పుడు మనకు వచ్చే బెనిఫిట్ ఏంటి, అండ్ రికర్సివ్ థింగ్ యూస్ చేసేటప్పుడు వచ్చే బెనిఫిట్ ఏంటి. యూ కెన్ సీ ఏ స్మాల్ ఎగ్జాంపుల్ హియర్. ఫర్ లూప్ ఇచ్చాము, ఫ్రమ్ n to 0 వీఆర్ జస్ట్ ప్రింటింగ్ దట్ వాల్యూస్, దట్స్ ఇట్. సో దీంట్లో ఎన్ని టైమ్స్ ఎన్ని ఆపరేషన్స్ జరుగుతున్నాయి, క్యాన్ ఎనీవన్ టెల్ మీ? n నుంచి 0 వరకు కంటిన్యూస్గా ఒక్కొక్క నెంబర్ ప్రింట్ చేస్తున్నాం, దట్స్ ఇట్. సో హౌ మెనీ ఆపరేషన్స్ ఆర్ బీయింగ్ హ్యాపెండ్ ఓవర్ దేర్? n, like for example, if n value is 5 print అవుతుంది once, 4 print అవుతుంది 2, 3 print అవుతుంది 3, అలా కంటిన్యూస్గా ఇట్ ఈస్ ప్రింటింగ్ లైక్ 5 times. 5 ఉంటే 5 times ప్రింట్ అవుతుంది, 10 ఉంటే 10 times, n ఉంటే n నెంబర్ ఆఫ్ టైమ్స్, రైట్? సో టైం కాంప్లెక్సిటీ ఏంటి ఇక్కడ? ఎన్ని ఆపరేషన్స్ జరుగుతున్నాయి? ఇఫ్ యూ ఆర్ యూజింగ్ లూప్స్, ఇట్ ఈస్ O of n. Now let's think about the space complexity. మనం ఇక్కడ ఈ స్టేట్మెంట్లో హౌ మచ్ మెమరీ ఆర్ వి యూజింగ్? we are just using only one variable, right? One variable అంటే like ఎంత మెమరీ యూజ్ అవుతుంది? It is obviously order of 1, right? Because like time complexity n ఎందుకంటే మనం n times అది రిపీట్ చేస్తున్నాం. Time is always about number of times you are executing something, right? అందుకని order of n వచ్చింది. And when it comes to order of 1, because అది ఒకవేళ ప్రింట్ మీరు 1 వేరియబుల్ పెట్టినా 2 వేరియబుల్స్ పెట్టినా కూడా it becomes O of 1 only, because order of any constant is 1. అదే ఒకవేళ మీరు ఫర్ ఎగ్జాంపుల్ n కాకుండా 2n 3n అలా వచ్చింది అనుకోండి, ఈవెన్ దాట్ ఆల్సో యూ కెన్ కన్సిడర్ ఇట్ యాజ్ n ఓన్లీ, రైట్? సో లైక్ వీల్ ఆల్సో డిస్కస్ అబౌట్ టైమ్ కాంప్లెక్సిటీ సపరేట్ సెషన్. ఇక్కడ విల్ జస్ట్ ట్రై టు అండర్స్టాండ్ హౌ ఇట్ ఈస్ వర్కింగ్ హియర్. So now in this case, since we are using only just one variable which is a constant, we are getting space complexity which is 1, right? We don't need to remember anything separately. Yeah, Pramita, you can ask. Yes. So Pramita, the concept here is like whenever we are working with big O notations, especially, like it is always either order of 1 or n log n or n power n square or 2 power n. ఇలాంటివి మాత్రమే వస్తాయి మనకి. We will not get n plus 1 or n plus 2 or anything, which n plus 1 or n plus 2. Exactly. Yes. Order of n plus 1 is nothing but order of n. Even order of n plus 5 is also equal to order of n. Okay? Yes, right. So now let's see the recursive approach. Recursive approach lo manam indake chusam. Like how do we calculate? Based on the tree structure, time complexity chestamu. Based on the stack structure, space complexity check chestamu. Now, if you are doing similar functionality here using recursive approach, already we calculated time complexity is O of n, space complexity is O of n, right? So now, which is better, iterative approach or recursive approach? Iterative approach is giving us O of 1 as a space complexity. Mari adi better, recursive approach better? Ideally speaking, this is preferable, but in terms of code readability, మనం ఇక్కడ చూస్తున్న ఎగ్జాంపుల్ ఏదైతే ఉందో దిస్ ఇస్ వెరీ సింపుల్ ఎగ్జాంపుల్. అందుకే మనం ఎప్పుడు కూడా నంబర్స్ జస్ట్ ప్రింట్ చేయడానికి ఇలాంటి వాటికి వీ డోంట్ యూజ్ రికర్సివ్ అప్రోచ్. వీ యూజ్ ఇట్ ఫర్ డిఫరెంట్ కైండ్ ఆఫ్ పర్పస్ వేర్ వీ కెన్ బ్రేక్ డౌన్ ద ప్రాబ్లమ్ అండ్ వీ కెన్ రైట్ ద like solution in a simpler and easy way. Alanti chotla we use recursive approach. Recursive approach is mainly to break down problem into multiple parts and solve one problem at a time in a easy way. It is not about saving some time or saving some space. It is more about like breaking down the problem and executing in a easier fashion. Okay? So now we already saw recursion means a function calling itself until a condition is met, right? We have already seen like indaka manam ee stack chusam kada, we call this stack as recursive stack. You can see. What do we call this? Recursive stack. Alage, and what do we call this tree? We call this as recursive tree. And ikkada indaka manam already anukunnam, like we want some base condition to come out of that particular function and all, right? So daniki there are three different ways. One is if n is equal to 0, like the other one is if n less than 1, or otherwise n greater than 0. These are the common like base conditions that we use. Got it? So now let's see, like indaka manam anukunnam, we thought of just printing the numbers from 1 to 10, and daniki we are calling from function of 10. So now here, yeah. So now let's focus on, like, manam anukunna four problems lo when and how to identify this particular problem. So there are four different factors. Sorry, five different factors. Yes. First one is what is the actual problem. Let's try to identify that. Indaka manam anukunnattu, in this case, this is like calling one function and which calls like n minus 1 as input for the like continuous stream. And the second one is identifying the smaller and sub problems. Did we do the same thing here? Function of 10 కావాలనుకున్నప్పుడు ఏం చేసాము? We found another sub problem which is like function of 9. And for 9, what is the sub problem? For function of 9, what will be the sub problem? Can you type it in? Yes, it is 8. Function of 8. Similarly, it goes on, right? Alage, if you take Fibonacci, ninna తీసుకున్నట్టు, if we say Fibonacci of 5, what are the sub problems? Do we have one sub problem or two sub problems? We have two sub problems, 4 and 3. And similarly, if we target for 8, what are the sub problems? Fibonacci of 8. There's 7 and 6, right? 6 and 7, either ways, they both are the same. So now this way we are trying to identify the sub problems. And then the third one is the key point, which is trust. You have to like assume that this particular function, whatever the input that you are passing, it will definitely give you a proper and perfect value. There shouldn't be any extra validation required on that output. If you have this kind of trust, then only recursive function will work properly. So you have to just assume that in the future, whenever you get some value, you are getting a perfect value. And finally, we are trying to just link. Yes. We are trying to link the actual and sub problems. How did we do that in Fibonacci problem? Fibonacci of 8 is equal to, we are linking the sub problems, Fibonacci of 7 plus Fibonacci of 6, right? So similar way, we are just trying to find a relation between the sub problems and the main problem. And finally, and most important part, which is the base condition. If you don't have a base condition, what happens? You will end up having a stack overflow problem. And whenever you are using recursion, there is a high possibility that you might get a high stack overflow like exception. And whenever you get that exception, what are we going to check first? Do we have a base condition? Do we have a termination condition? You need to just check that first. If that is there, then automatically it will work properly. There won't be any issue. Got it? So if you follow these 5 steps, finding the actual problem, breaking down it into smaller problems, and then assume that your sub problems will give you proper output, and then just try to link the actual problem and sub problem together, and then check your base condition. If you can do all these 5 things, then you can use recursion properly. So even here also you can see function of 10 means we are calling function of 9. Function of 9 means again we'll call 8. 8 means 7. It just keeps on going on. So we can also see the same thing here. It's basically we have a stack, and then we are just pushing and popping. Yes. Yeah. So can anyone tell me what is the output of this particular function? there is a function n as a parameter, and if n is greater than or equal to 0, we are calling function of n minus 1, and after that we are calling a print statement of n. So what will be the output of this? If I pass, let's say, like 4 as a input, what will be the output? 43210. Okay. So no output. Okay, right. Now let's try to understand this. So this example is mainly to understand how the methods actually work. So first one, we went with 4 as an input, right? When 4 goes inside, if condition, true or false? 4 greater than or equal to 0. It is true. So it will go inside. Now, first of all, this Fibonacci function of 4 is going into a stack. Right? Now, we are done with this line. Next, this line. Will it give you output immediately, or do you need to calculate this again? This will go here, right? So it is calling function of 4 minus 1, which is, it is going to get added into stack function of 3. So which means function of 4 ఇంకా complete అవ్వలేదు, and we did not even cross this line actually. If you see, print statement work అవుతుందా ఇప్పుడు? It won't work until this line is completely done. So now we have passed 3. 3 greater than 0, true. 3 minus 1, it is calling function of 2. Right? Next, 2 వెళ్ళింది, 2 greater than or equal to 0. So function of 1. And then now 1 greater than or equal to 0. Even this also passed. Function of 0. Next, if n is greater than or is equal to 0. So ఇది కూడా పాస్ అవుతుంది. అండ్ దీని లోపల ఏమవుతుంది? ఫంక్షన్ ఆఫ్ n minus 1. 0 minus 1 ఏంటి? Function of minus 1. Now, if you see this condition, is this condition true or false? This is false. Will it go inside? These two lines are skipped, so it will come out. Now, ఈ method complete అయిపోయింది అంటే we are actually deleting this particular function from the stack, right? Yeah. Yes. So this is deleted now. And then next, f of 0, మనకి f of 0 ఇక్కడ క్యాలిక్యులేట్ చేసేటప్పుడు we are at this place, right? This is completed. Now the next line actually prints. What is the n value ఇక్కడ? It is actually 0. So what are we trying to print? We are printing 0. Then 0 print అయిన తర్వాత ఈ మెథడ్ కూడా అయిపోయింది. This will get cleared from the stack, and now we have 1. So 1 దగ్గర ఈ లైన్ అయిపోయింది. And what are we trying to print? What is the n value? It is 1. So we are printing 1, right? Next, ఇది కంప్లీట్ అయిపోయింది. Next 2, we are printing 2. So this is how we are going to print. Since we have called the recursive function before print statement, total order change అయిపోయింది, if you observe, right? If I just change this order, what will happen? Yeah, you can see here. If I just change the order, what will happen? If I pass 4 compare చేస్తుంది, and it is printing 4 first. So 4, and then it is calling the recursive function 4 minus 1, which is 3. So ala, this is going to print something like this. So just ఒక లైన్ పైకి కిందికి మూవ్ చేయడం తోటి the total order has changed. Can you observe that? Can you observe that? Yes. And ఈ pattern we use it a lot, like especially using when we are working with trees and all. Like whenever you are passing with trees and all, we use this pattern a lot. Reorder, pre-order, post-order, in-order traversal. When we are working with trees, you'll get to know those kind of things. And recursion ఎందుకు అంత simple and easy to understand అన్నది we'll get over there. Now, let us see like one small example. So, I want to print something like this. Okay, 3, 2, 1, 1, 2, 3. How should I do that? First of all, like when you have this kind of pattern, what are we trying to identify? We want to find sub problems and actual problem, right? So now this entire thing is actual problem. Now we are trying to identify sub problem with a similar pattern. సేమ్ ఈ పైన ఎలా అయితే ఉందో అదే విధంగా ఉండే ఇంకొక ప్యాటర్న్ ఐడెంటిఫై చేశాను. నా దీని లోపల ఇంకొక చిన్న ప్యాటర్న్ కావాలంటే దిస్ ఈస్ అనదర్ స్మాల్ ప్యాటర్న్, రైట్? సో నౌ ఇఫ్ యూ ఐడెంటిఫై దిస్ ప్యాటర్న్, ద లాజిక్ ఈస్ వెరీ సింపుల్. First, you are trying to call with 3, and then you are trying to call with 2, and then you are trying to call with 3 again. So this way, when you are trying to do, it will automatically print in the same order that we have used previously. So ఇక్కడ ఫస్ట్ ప్రింట్ చేస్తున్నాము, లాస్ట్ ప్రింట్ చేస్తున్నాము, మధ్యలో what do we have in the middle? It is a recursive function. Okay, is it clear everyone? సో మనకు ఇలాంటి ఒక బ్యూటిఫుల్ ప్యాటర్న్స్ రావాలి అంటే వెన్ యూ ఆర్ యూజింగ్ రికర్షన్ ఇట్ ఈస్ వెరీ సింపుల్. వెన్ యూ ఆర్ యూజింగ్ ఇటరేషన్ లైక్ లూప్స్ అండ్ ఆల్, ఇట్ బికమ్స్ లిటిల్ ట్రిక్కీ ఇన్ అండర్స్టాండింగ్ ద కోడ్. When it is in the like recursion, it is much simpler actually. Got it? So here you can see the example also. First, we are taking one input which is a number n, and what is the base condition? We are returning whenever the number n is actually 0, and then we are trying to print this number, and then we are calling the recursive function, and we are again printing the number. So now if you see, then okavela 4 పంపించాను అనుకోండి, first if condition fail fail అవుతుంది కాబట్టి it is coming the next line, 4 is getting printed. Next, ఇప్పుడు ఈ లైన్ ఎగ్జిక్యూట్ అయ్యేటప్పుడు ఇక్కడ we are getting some output, but I don't know what exactly it is, and finally at the end we are printing n again, which is 4, right? So now ఇప్పుడు ఇక్కడ ఫంక్షన్ n-1 అని వెళ్ళినప్పుడు it is becoming 3. So first again it prints 3, మధ్యలో again we don't know what exactly it is printing, again it is printing 3 here. So ఇలా when you start printing it, you will get this kind of beautiful pattern. So whenever you see this kind of patterns, there is like a highly great chance that you can use recursion in such patterns, but you need to observe that relation between actual problem and sub problems. So whenever it comes to recursion, it is not about coding, but it is about analyzing the problem first. If you are not able to analyze the problem, it becomes very difficult. Okay, shall we just try to run one example and see like whether it will work properly or not? Shall we try for this example? Yeah, let's open the one compiler we have been using it, right? So first let's try to write a method. Let me call it as like a print. I'm just writing the method name as print pattern. And what is the input? We need some number, right? I'm just giving n. Now what should we do inside? The first thing we should always do is base condition. What is the base condition? If n is equal to 0, what should we do? Return. We don't want to go forward anymore. Now first we wanted to print the n value, right? n, and we have already seen first last మనకి n value కావాలి. So I'm just going to write that also. Now middle sub problem ఏంటి? We have to call the method again, print pattern, and what are we trying to print? n-1. That's it. Now we'll call this method in the main method and we'll see whether it will work or not. Let me call for 5. Yeah. Did we get this pattern now? 5, 4, 3, 2, 1, 2, 3, 4, 5. Yeah, sorry, 1, 2, 3, 4, 5. Right. So now, if we have to use for loops, how will it be? You have to write two different loops basically. It will be like for int I equal to n, I greater than 0, I minus minus, and then you have to print n value. No, sorry, I value. And same thing you have to again increment it now because we need to print from 1 to n also, right? I equal to 0 less than or equal to n, I plus plus. Yes, and we are printing from 1, right? So let me put it as 1. And then we are printing the I value. Let me comment this and see if this works. Yes, so even this also works. Now, if you see which is easy to read and understand, for loop flow, like is this better or is this better for reading purpose and understanding purpose for maintainability? Iterations or recursive? Recursive might be a little difficult to understand in terms of like how to apply recursion and how to understand when to use it and all. But it makes our code look much simpler and easier. That is the primary reason why people use recursion. And whenever you use trees, recursion is a savior actually. If you use iterations, like with trees, it is like very, very difficult and very challenging. When we use recursion, it becomes much simpler to use. So that's the reason we have been working with the recursion part. So now let's just try to understand one more example. Yeah. So like when we actually work with Fibonacci, this is how we work, right? మనం ఒకవేళ Fibonacci of 5 కనుక్కోవాలంటే we created two nodes which are n minus 1 and n minus 2, and for 4 we have created again another one which is 3 and 2, 2 and 1 for 3, అలాగే 2 కి మళ్ళీ 1 0. We have created a complete tree like structure. Almost ఈ functions అన్ని execute అయితేనే we can like find function of 1. Yeah, we can find the value of function of Fibonacci of 5, right? If you go even upper, ఇంకా పెద్ద numbers తీసుకున్నా కూడా the process remains same. Now, how to calculate the time complexity and space complexity in this particular case? So, can anyone tell me what is the time complexity here? ఇక్కడ ఎంత టైం పడుతుంది, ఎన్ని ఇటరేషన్స్ జరుగుతాయి, లైక్ ఎన్ని టైమ్స్ కాల్ అవుతుంది? How many times is it calling actually? For example, 5 ఉంది. 5 ఎన్నిటిని కాల్ చేసింది? It called 2 elements, right? 4 and 3. Again, ఈ 4 మళ్ళీ ఎన్ని కాల్ చేసింది? 2. 3 and 2. 3 it called 2 times again. So ప్రతి node it is actually calling 2 different times, right? And when it comes to like calculating these complexities and all, it always depends on one major thing, which is the length and number of levels. So now the length will actually give you the space complexity. ఇక్కడ టోటల్గా ఒక మాక్సిమం లెంత్ ఎన్ని ఎలిమెంట్స్ ఉన్నాయి చెప్పండి? ఓవరాల్గా లైక్ హౌ మెనీ ఎలిమెంట్స్ డు వీ హ్యావ్? 1 2 3 4 5, which means మన n value అయినా our n value is 5 and the longest like ladder that we have is also 5, which means the time space complexity is order of n. Now let's try to see the like the number of levels. మనకు టోటల్గా ఎన్ని లెవెల్స్ ఉన్నాయి చెప్పండి. ఫస్ట్ లెవెల్ ఇస్ f of 5, సెకండ్ లెవెల్లో 4 and 3 ఉన్నాయి, థర్డ్ లెవెల్లో 3, 2, 2, 1 ఉన్నాయి, ఫోర్త్ లెవెల్లో వీ హ్యావ్ దీస్ ఎలిమెంట్స్, ఫిఫ్త్ లెవెల్లో వీ హ్యావ్ దీస్ ఎలిమెంట్స్. సో హౌ మెనీ లెవెల్స్ డూ వీ హ్యావ్? వీ హ్యావ్ 5 levels, రైట్? సో టైం కాంప్లెక్సిటీ వచ్చేసరికి మనకి O of 2 power n అవుతుంది. And why 2 power n? Because every child has 2 elements. And ala any times repeat అయింది? 1, 2, 3, 4, 5. So since we have 5 different levels, we have the time complexity will be 2 power n. Now this is what for Fibonacci, right? ఒకవేళ నేను Fibonacci అని చేశాను అనుకోండి. Fibonacci అంటే f of 4 plus f of 3 plus f of 2. అలాగే ప్రతి దానికి కూడా ఇలా 3 ఎలిమెంట్స్ వచ్చాయి అనుకోండి. అప్పుడు వాట్ విల్ బి ద టైం కాంప్లెక్సిటీస్ అండ్ స్పేస్ కాంప్లెక్సిటీస్? స్పేస్ కాంప్లెక్సిటీలో ఏమైనా చేంజ్ ఉంటుందా మనకి? When we are calculating space complexity, did we consider anything about number of children? We did not consider number of children, right? We considered only the longest length in a particular like tree, longest ladder basically. So this remains same even in Fibonacci also, O of n. And when it comes to time complexity, does it have anything to do with number of children? What is this 2? Why did we get this 2? We got this 2 mainly because we have every element has 2 children, right? 2 possible children. But in this case, how many children do we have? 3 children. So what will be the power? Exactly. So Tanvishri, it is 3 power n. So the time complexity will be O of 3 power n. So it depends. Time complexity depends on number of children and how many times you are calling a particular method. Space complexity depends on how many times a particular method is being saved in a stack. So that is how we actually calculate time complexity and space complexity. Any questions so far? Guys, even ఏదైనా చిన్న క్వశ్చన్స్ ఉన్నా కూడా you can ask me, no issues, okay? And we also have a question and answer session. మీకు ఇంకా ఏమన్నా like doubts అలా ఉన్నా కూడా we can discuss over there, don't worry, okay? So this is how we can actually like break a problem into multiple things and then we can use it. So now can we just try to understand one simple example? Real life lo manam use chese example okati, we'll just try to understand that. For example, meeku 5 cards ichanu anukondi and I wanted you to understand like ee 5 cards ni different what is it like arrangement cheyali. How many possible arrangements can be done? We have these cards, let's say 1, 2, 3, 4, 5. Now how are you going to like identify whether how many possibilities of arrangements are possible with these 5 cards? Yeah, let's take ABCD. So first is రాగానే మనకి ఏం గుర్తొస్తుంది? Okay, it has something to do with a large set of what is calculations లేదా మన మ్యాథమెటిక్స్ చిన్నప్పుడు యూజ్ చేసిన ఫ్యాక్టోరియల్ ఇలాంటివి, రైట్? నౌ లెట్స్ జస్ట్ ట్రై టు అండర్స్టాండ్. ఇది 5ని 5 లాగా ఇంత పెద్దగా తీసుకునే కన్నా జస్ట్ టేక్ 2. ఒకవేళ 2 తీసుకున్నారు అనుకోండి, హౌ మెనీ పాసిబిలిటీస్ ఆర్ దేర్? ఏబి అండ్ ద అదర్ వన్ ఇస్ బిఏ, రైట్? నౌ ఇఫ్ యూ గో ఫర్ 3, what happens? ఈ 2 possibilities definitely cover కావాలి, right? At the same time you have to place C also in such a way that it can be used in different ways. For example, it can be C A B or otherwise ఇంకా ఏం రావచ్చు ఇక్కడ? A C B and A B C, right? అలాగే ఇక్కడ ఏవేవి రావచ్చు? B A and దీని ముందు C B, C, A, B, A, C. We are just, if you observe, like, we are just placing this element at a different places. C. C ni first place to పెట్టా, second place to పెట్టా, third place to పెట్టాను. And ikkada same thing, first place, second place, third place. And by keeping this, we are able to identify how many patterns we can do, right? 2 ఉన్నప్పుడు ఎన్ని వచ్చాయి? For 2 we have got 2 possibilities. 3 ఉన్నప్పుడు ఎన్ని possibilities వచ్చాయి? 1, 2, 3. అలాగే 4, 5, 6. 6 possibilities వచ్చాయి, right? Now, when it comes to 4, what happens? ఈ 6 పాసిబిలిటీస్ తీసుకొని ఈ 6 పాసిబిలిటీస్లో ఫోర్త్ లెటర్ దీన్ని ఎక్కడెక్కడ పెట్టచ్చు అనేది we will calculate. And if you try to observe this pattern, it finally goes into something like a factorial problem. What do you mean by factorial? If you see here, like 2లో 2 ప్యాటర్న్స్ వచ్చాయి అండ్ ఈ ఒక్కొక్క ప్యాటర్న్ని మనము సి లెటర్ తోటి లైక్ వి ఆర్ ఏబుల్ టు క్రియేట్ ఇట్, రైట్? ఒక ప్యాటర్న్ని ఒకసారి ఇక్కడ 3 వచ్చాయి, ఒకసారి ఇక్కడ 3 వచ్చాయి. సో బేసికలీ వీఆర్ మల్టిప్లైయింగ్ 3 and 2, right? And what is the output? We got 6. So now if we give 4 as the input, what will be the output? We know that for 3 it is 6, right? For 4, what will be the value? It will simply be 4 into 6. What is the value? 24. And even if you go for 10 also, it becomes the same thing. So we are able to find a pattern over here, right? So ఇప్పుడు మీకు 5 కావాలనుకోండి, 5 చేయాలంటే ఏం చేయాలి? f of 5 is equal to 5 into f of 4, right? Factorial of 4 basically. అలాగే 4 కావాలంటే ఏం చేస్తారు? You'll do the same thing again. 4 into factorial of 3. So once you find this pattern, just కావాలంటే మీరు ఒక పేపర్ మీద try to draw it and see how it works. Then you can easily understand that, okay, this problem is nothing but factorial problem. Factorial problem అంటే డైరెక్ట్ జస్ట్ గుర్తుపెట్టుకొని బట్టి కొట్టి చేయాల్సిన అవసరం లేదు. Once you try to do a small example on a paper, you'll get full clarity on how to use that. And then you'll find a formula or a pattern. A pattern ni base cheskoni you can determine whether you can use recursive functions or not. And iterations vaadite better output untunda annadu kuda you can think and you can plan accordingly. Is it clear? So what we did was we just got one problem which is like a set of cards వీటిని అరేంజ్ చేయాలి. 5 అనుకున్నాను కాబట్టి it was easy to understand. అదే ఒకవేళ నేను లైక్ టోటల్గా 52 కార్డ్స్ ఇస్తాను, అరేంజ్ చేయండి అన్నారు అనుకోండి, ఈజ్ ఇట్ ఈజీ టు క్యాల్కులేట్ మాన్యువల్లీ? It is very difficult, right? So instead of doing that, we can directly do it in a programmatic way. Now shall we try to see, like ఒకవేళ 52 ఇస్తే ఓవరాల్గా ఎన్ని ఆపరేషన్స్ జరుగుతాయి, ఎన్ని టైమ్స్ అది ఎగ్జిక్యూట్ అవుతుందో? Shall we try to see? We'll just write a small sample code, the same thing ఇక్కడ మనం ఇందాక రాసినట్టే. Void factorial of int n. And what is the base condition? మనం ఎప్పుడు ఆపాలి? If n is equal to 1, can we return? Because 1 into 1 చేసినా కూడా it's the same value, right? So we are saving one operation basically. And what should we do? Factorial ante we are expecting some output, so we need to return the value, right? Return n into factorial of n minus 1. Done. So if I try to call this method, sorry, okay, yeah, there is a small typo. N into factorial of n minus 1. Now let's call this method factorial of 5. What should be the output for factorial of 5? Okay, return 1, because factorial of 1 is also 1, right? We are not displaying anything, so that's the reason it did not display anything. So let me store this in a result. and then I'll try to print this. Yes, we got 120. 5 into 4 into 3 into 2 into 1. Now, I want to see how many operations actually happen. అలా చేయాలి అంటే I need some external variable, right? Counter లాంటిది ఏదైనా. So I'm just going to create a variable at a global level. Static int count equal to initial ga 0. And whenever this is being called, I'll just increment that. Count plus plus. So now after this, we'll also display how many operations happen. సో 5 చేసేటప్పుడు ఏమైంది 5 తర్వాత 4 3 2 1. సో ఓవరాల్గా వీ హ్యావ్ గాట్ 4 సబ్ ఆపరేషన్స్, రైట్? అదే ఒకవేళ ఇఫ్ ఐ గివ్ అ బిగ్గర్ నెంబర్, ఇందాక మనం అనుకున్నాం కదా, ఇఫ్ యూ గివ్ 52, వాట్ విల్ బి ద అవుట్పుట్? Just a minute, guys. No, it is not. Yeah. Hello, can you hear me? Just type yes. Okay. Right. Okay. Right. So this way we are able to identify the number of sub problems actually. So 52 ఇచ్చినప్పుడు ఏమవుతుంది? We are calling from 51, 50, 50 like 49 and all. So Allah, we are making 51 operations overall. But finally the output we got is 0. And why is that? 52 ఇచ్చినప్పుడు 52 factorial ఏంటి ideally? Is it a small number? 52 factorial, is it a small number or a big number? It is a very big number. So it was not even able to store that much amount of like value. So let's try to give a small number and we'll print it. 10, it worked. Let's give 20. అది ఎక్కడ బ్రేక్ అవుతుందో we'll try to see. ఏ number దగ్గర అది ఇంకా like it is not able to do that. Yeah, now we got minus number, which means 20 లోపే బ్రేక్ అయిపోయింది. So what number should I give to check ఎగ్జాక్ట్గా ఏ నెంబర్ దగ్గర బ్రేక్ అవుతుంది? Let's try for 50. Okay. For 15 also. So we are trying a binary approach, if you observe, right? 15 ki kuda positive number vachindi. So it might be 16, 17 or 18, 19, those numbers, right? 16 also it worked. Let's try 18. But it broke. So till 17 we are able to find the factorial number. Not even 17, till 16 only. So after 16, it is crossing integer limit basically. So that is the reason it is not able to show a number which is greater than that particular value. If you want to work on those kind of numbers, which data type should we use? We have to use long. Like even at multiplication, internal variables, everything you have to use long so that you can see whether it works or not. So just try it out using long and see if you are able to come up with up to like 25 or 30 numbers, and we'll see that. So guys, like we already have multiple problems on recursion on the platform. You can just go through them. Like you have all the content with all the explanation and everything. You can just try to practice them on one compiler, or you can do it on your own like editor also. And once you're done with it, you can just share the screenshot on the Discord. Okay. So that's it. On top of recursion, guys, like tomorrow we are going to cover new topics, mostly on hashing mechanisms. So one of the most powerful and very important concept in terms of top companies. Whenever you go for top company interviews, hashing mechanism plays a key role because it gives you of one complexity all the time. So that's the reason it is one of the key points. Tomorrow, let's discuss in depth about hashing, how to do hashing, and how are we going to use hash maps, hash set, hash tree. There are multiple concepts. So we'll go through them and we'll try to practice them. So yeah, that's it for today, guys.